Well, let's make a start with that first topic in this program. It's about units, the metric unit system, Système International. They call it actually SI. And if you look at this, we have 7 basic units. One is length, that's the unit for that is a meter, symbol M. We've got mass, the unit for that is kilogram. Then time, that's measured in seconds. And the current, that is to do with electricity, is measured in amperes. Now there are some other ones, but we don't really use those much at all. Now the nice thing about the metric system is that all the units are related to these 7 basic units. For instance, if you talk about a Newton, then that can be expressed in a combination of those 7 basic units. There are also conversion factors that relate these units. For instance, kilo means 1,000. We already know that. But there are some other terms used in engineering that you should be familiar with. Let's have a look at those. If we look at some large prefixes, as they're called, then the first one we come across is tera with a symbol T, capital T. There's a giga, and you might have heard of a hard disk drive that has, for instance, 20 gigabytes. 10 to the power of 6, that means a million, is mega. 10 to the power of 3 is kilo. 10 to the power of 2, hecto, not used very much, and a deca as well. Now those are units for large measurements. Now there are also units for very small measurements, and I've got those listed coming up. We've got pico, that is 1 over 10 to the power of 12. That is symbol P. We've got nano, so you could have something called a nanometer. Micro, and that symbol you see over there is mu, is pronounced mu. And then milli, we're all familiar with, that's 1,000th. And then there's a centi, 100th, not used very much in engineering. And then we've got a deci, and that's hardly ever used. There are some very specific units. When the metric system was introduced, people were worried about having to express things in terms of 1,000 kilo. We were familiar with the British ton, and so some units were introduced in the Australian metric system that are quite specific. For instance, we talk about a ton. At 1,000 kilograms, and the abbreviation there is a small t, and notice the spelling. And hectare, to use with area measurements, that's equal to 10,000 square meters, or 100 meters by 100 meters. And finally, we also use a liter, which is the same as 1,000 cubic centimeters, and the abbreviation for a liter is capital L. Now let's have a look how we can use these prefixes in conversion problems. And I've got a problem on the board, and hopefully before the answer is given you are already able to give the answer. Let's have a look how that works. First problem I've got on the board here, or on the screen, talking as a school teacher, as you notice on the board, we've got a screen here. Convert 102 kilometers to meters. Well, pretty straightforward, because we know, of course, that there are 1,000 meters in every kilometer. And so if we multiply 102 by 1,000, or 10 to the power of 3, we get the answer as 102,000 meters. Problem 2, a little bit more difficult. That's the way it normally will go. We start with an easy problem and then get into the more difficult problems. Problem 2. Convert 268.5 micrograms to grams. Now, a microgram is 1/1,000,000th of a gram. So we're going to get a number with a lot of zeros in front, because we're going to get a very small number. Here we go. The conversion factor is 1 over 10 to the power of 6. That's the same as dividing by 10 to the power of 6. And as you can see, you get lots of zeros, because when you divide by 10 to the power of 6, as in this problem, that decimal point you see over there has to move 6 places to the front, and you have to introduce these extra zeros to be able to place that decimal point. Let's have a look at a slightly more difficult problem. And here we go. We've got convert 10.5 square meters to centimeters squared. When you convert squared units or cubic units, there is going to be a slight difficulty. You can't just, multiply by 1,000. You have to take into account whether it's a squared unit or a cubic unit. Typical problem here. We've got 1 square meter as 100 centimeters times 100 centimeters, so I'm already changing to the squared there. So that's going to be 10,000 squared centimeters. And then finally we want to have 10.5 square meters, so that number there has to be multiplied by the 10.5 to obtain in the end 105,000 squared centimeters. And that's the way it works in problem 4. We've got in problem 4 how many gigaliters in 531 cubic meters. Now a cubic meter is actually 100 times 100 times 100 cubic centimeters, and that makes it 1,000,000 cubic centimeters. Why do I change it to cubic centimeters? Well, a cubic centimeter, 1,000 of those make 1 liter, so I get 1,000 liters. And that's not a bad thing to remember, that 1 cubic meter is equal to 1,000 liters. We want to know how many gigaliters there are. Well, we have to divide by 10 to the power of 9 because the giga is related to 10 to the power of 9. But we've got already 1,000 liters, so it's really divided by 10 to the power of 6. And finally, if you work that out on the calculator, you get 0.00. You got again the decimal point moving 6 places to the front. Quite a difficult problem, that one. You might have to look at that in more detail and practice those sorts of problems from your book.